All right, so I want to talk a little bit more about this problem here. We were having some issues with it because we got down to the bottom here and wondered what calculations we would have to have. Well, come to find out, the textbook I pulled this from has different values and different half reactions. So there's actually a half reaction that is more closely related to that, and we actually have the silver chromate going to the silver solid and the chromate ion. So I want to rework that a little bit, and not that we would have gotten anything wrong here, it's just that they had a more specific reaction here, and when we get that more specific reaction, the Ag, it was Ag2CrO4 goes to Ag solid, and then it was plus, over here this is plus 2 electrons. This voltage, this E, was actually 0.45. Okay, and so then when we have this, instead of 0.45, we get 3.50 volts. Okay, and so with that, then what we see is that we're really close to the value. It is the same value, if you will, and so it's pretty much the same value, which means that here these two are equal. Okay, which means that this has to go to 0. And so in part D, it asks what would the EMF be at a body temperature? Well, our concentrations are equal because we've got an E close to E standard, and so that means it would still be 3.50, okay? And our temperature wouldn't matter. So that helps explain that one a little bit better. I've already tweaked that one a little bit for next year. All right, on example 8, it tells us that we have a period of discharge of a lead acid battery, and it gives us 402 grams of lead from the anode is converted to PbSO4. So it's going to tell us that our oxidation half reaction, our anode, is going to be Pb going to PbSO4. And then it tells us that we have lead-2 being reduced. And so Pb that should be lead 4 oxide, by the way, but that's okay. Going to, this also is going to go to PbSO4. Okay, and I pulled that out because I've got 2 half reactions from this other textbook that I pulled this from. We've got PbO2 plus HSO4 negative plus 3H plus. So I've got this half reaction here. So let me go ahead and write that down, and then the other half reaction goes the other way, that way. So let me write that down for us. So that's plus HSO4 negative plus 3H plus 2 electrons. And up here, our Pb is plus HSO4 negative, and that yields an H plus and 2 electrons. Our voltage for this one was negative 0.356 volts, and then we have for the other one 1.685. Okay, and so when we take a look at this, we can add these two together. I'm going to see that one of the H pluses cancels out, my electrons cancel out, and I'm left with Pb plus 2H SO4 negative plus PbO2 goes to 2PbSO4. And I left something off. I had to because I've got H's. I did. This one has plus 2 waters. To plus 2 waters here. Okay? And so both of these go to PbSO4. So this is my reaction here. Now, I want to know what mass of lead 4 oxide is reduced at the cathode during the same period. Well, it tells me I have 402 grams here, and it wants to know grams here. Grams here. So, how can I predict the number of grams? Do stoichiometry. To 402 grams of Pb, grams of Pb to moles of Pb, 1 mole of Pb to 1 mole of PbO2, and then 1 mole of PbO2, 2 grams of PbO2. So this is just an old school stoichiometry problem. Now, I have a molar mass of 207.2 grams for lead, and for lead 2 oxide it's 239.2 grams. And when I work that out, I come out with 464 grams of PbO2 is going to be used up. Part C wants to know how many coulombs of electric charge. So here, coulombs, again, coulombs is electric charge. And we know of coulombs from Faraday's constant. And so we can use Faraday's constant to help us out. Again, if I go back and look at what Faraday's constant actually is, all the way back here, it's coulombs per mole of electrons. Well, that's a conversion factor right there. And so I can use the same 402 grams of Pb, 1 mole of Pb, and I can go from moles of Pb, again because it happens to be 1-to-1, to my moles of electrons. Well, how many moles of electrons was converted? 2. And then once I have moles of electrons, I can go to coulombs, which is Faraday's constant, 96485 coulombs. And when I do that, I'm going to get 374,000 coulombs of charge is being moved. Okay? Alrighty. So that's going to be it for E7 and E8.